There's a telescope in space named after Edwin Hubble. He's the astronomer who proved the universe is expanding. It's one of the biggest scientific discoveries of the 20th century. What most people don't know is that Hubble's entire career rested on a single mathematical law, a law discovered 15 years earlier by a woman who was paid 25 cents an hour to stare at photographs of stars. Her name was Henrietta Swan Leavitt, and she gave us the ruler we use to measure the size of the universe. At the turn of the 20th century, Harvard College Observatory had a problem. They had thousands of photographic glass plates of the night sky and no one to look through them. So they did something that sounds bizarre now. They hired a group of women to do it. They called them computers. Not the machines, the people. They were paid less than half of what the male astronomers made. They weren't allowed to touch the telescopes, and their job was to catalog, by eye, every star on every plate. Henrietta Leavitt joined them in 1893, at the age of 24. She was assigned a specific task: find the stars whose brightness changed over time. There's a class of star called a Cepheid variable. It pulses, getting brighter, then dimmer, then brighter again, on a clockwork cycle. Some cycle in a day, some take 100. Leavitt started finding them, first in the Magellanic Clouds, two small galaxies near our own, and she noticed something nobody else had. The slower a Cepheid pulsed, the brighter it was. Every single time, a Cepheid with a 30-day cycle was always brighter than one with a 3-day cycle. It was a law. And because all of her Cepheids were in the same galaxy, roughly the same distance from Earth, their apparent brightness was directly comparable. You could look at any Cepheid, anywhere in the sky, time how long it took to pulse, and from that alone calculate exactly how bright it really was. This is the moment that matters. If you know how bright something actually is, and you can measure how bright it looks from Earth, you can calculate exactly how far away it is. Before Leavitt, astronomers could measure distances out to about 100 light years, and that was it. After Leavitt, they could measure distances to anywhere in the galaxy, and beyond. She had given astronomy its first cosmic yardstick. She published the paper in 1912, 3 sentences of math that quietly rewrote what it meant to know where anything in space actually was. 1923, Edwin Hubble pointed the largest telescope in the world at a fuzzy smudge of light called Andromeda. He found a Cepheid variable in it. He timed its pulse. He applied Leavitt's law. And the answer came back. Andromeda was nearly 1 million light-years away, far outside our own galaxy. For the first time in history, we knew there were other galaxies. 6 years later, in 1929, he did it again with dozens of galaxies, and noticed they were all moving away from us, faster the farther they were. The universe was expanding. Modern cosmology was born that day, on top of her ruler. She didn't live to see it. Henrietta Leavitt died of cancer in 1921, at the age of 53. She was a junior staff member at Harvard until the end. In the papers that built Hubble's career, she is referred to as, quote, Miss Leavitt. Never co-authored. A Swedish mathematician tried to nominate her for the Nobel Prize in 1925. He didn't realize she had already been dead 4 years. They don't award the Nobel posthumously. Every galaxy in every image the Hubble Space Telescope has ever taken has a distance attached to it. That distance was calculated using a rule Henrietta Leavitt discovered, by eye, off a glass plate, for 25 cents an hour, 100 years ago. The telescope is named after the man who used her ruler. Think about that. If you want to read more, Miss Leavitt's Stars by George Johnson is a great place to start. Link in the description. If you liked this, subscribe. We do a lot of stories like this, things that were real, or almost real, that most people have forgotten about. I'll see you in the next one.